Hey Jesse, we already started recording, so we're grading section 4.2 right now. So I'm just going to zoom through it really fast, pause if you need to check anything. So there's 4, there's 6, there's 18, there's 30, and now we're on 40. Okay, so we have cosine t of negative 3 over 4. Cosine is even or odd? Even. Even stays the same, so you just get to steal the negative 3 over 4. Secant, even or odd? Even, because he's just like cosine, he's the reciprocal. So we can go ahead and once again, steal the negative 3 over 4, but we have to flip it because it's secant. Secant is the reciprocal of cosine, so we flip the fraction but keep the sign.
Well, would it be positive, yeah?
Because, remember, cosine is even. And so in that chart that we did in class, cosine of negative t is equal to cosine of positive t. They stay the same. Or if you think about it, if we go up, give me an angle. Pi over 6, is that okay? Almost pi over 4. But not quite pi over 4. Anyway, if we go up an angle, we would have sine, over a lot, which would be root 3 over 2. Up a little, which would be 1/2. But what if we go negative an angle? The sine flips because you're going down. But the cosine stays the same because you're going to the right.
Cosine is right.
So cosine is the same whether you're going a positive angle or whether you're going a negative angle. Sorry, those are thetas. Does that make sense?
What if it's
So cosine stays the same.
2 or 3?
Well, see, that's what this one is though, right? Because this one cosine is negative. So then it'd be over here, maybe. Is one example. 3 over 4, that's not very accurate, sorry. It should be taller than it is. Why? So we'd be like up here. Okay. So then negative 3, positive 4. So we'd have negative 3, positive 4. But then the negative angle would go down here, right? We would have negative 3, negative 4. The sign still flips, but the cosine still stays the same. So if one's negative, the other's negative. Because the x stays the same, and that's the cosine. So see, cosine the same as whether you go positive angle or negative angle. And this one, cosine stays the same whether positive angle, negative angle. So that's why negative angle didn't make difference. Cosine is going to be the exact same thing. Secant, since he's 1 over cosine, stays the same also, but secant needs to flip the cosine because it flips. But there are also formulas in section 4 too. I think we wrote down on Friday, right? I think we ran out of time on Thursdays, so maybe we get those ones down in notes. We have 2 more, right? Or 1 more? 60? Anything else? Just 60. I have no idea what the question was. What was number 60's question? What's letter A? Trigonometric ratios. Is that it? Oh. Did they give you something like sine and cosine exist? There's asking if they exist. Or when do they exist?
Let's get the full time.
Oh, well, my book just froze. That's fun. Oh, there's Spider-Man. Number 60. Oh, okay. It gave us a picture. You guys didn't get the picture down? Oh, okay. Question. What's sine? I don't know. What's cosine? I don't know. They're both negative and they're both numbers. Meaning non-zeros. Why? The only way they'd be, or one of them would be a 0 is if the point was where? On the y-axis or on the x-axis. So since it's not, I know that both of these are numbers and they're both negative numbers. So when letter A says, do all the trig functions exist? The answer is, of course, yes. Because the only time they don't exist is when you're dividing by a 0. And if neither of those are 0, are we going to have to worry about it? Okay, neither of them are 0, according to the picture. It's in the second and third quadrant, and they're both numbers, so non-zero constants, I should say, to be all spiffy. So therefore, they all exist because there will be no division by 0. Letter B says, for those trig functions that exist, determine whether the function is positive or negative. That's a good one. Sean, what's up? Yeah, go for it. Can you give me some reasoning as to why?
Yes.
Okay.
The sine, cosine, cosecant, and secant will all be negative because the placements in the quadrant 3, and then the tangent and cotangent will be positive because when we're doing the tangent, we're taking the line, we're dividing it by the x, so it would be negative divided by negative.
Aha! Is that pretty much what he said? Sine, cosine, secant, cosecant, all of theta. I forgot to put the thetas, and I felt guilty, so I put theta afterwards. All of those of theta are going to be negative because sine, the y is negative third quadrant, x, the x is negative third quadrant. 1 over x will be negative because x is negative, and 1 over y is going to be negative because y is negative. All of those are negative, but tangent and cotangent, as Sean said, are both positive. Since a negative over a negative is a positive. There you go. Dun, 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 dun. All right, let's put this homework away. Let's get back to our notes.
How did it go? Like quadrant 1, sine is always positive. No.
Don't worry. We're going to use today to review the unit circle. Did I save that?
Quadrant 3's tangent is always positive.
Hold on. We have time to review today. Hold on. All students stay comfortable.
Yeah.
Oh, there we go. What did you guys do? Oh, Jesse, by the way, this was warm up in notes, I think, right? I didn't have you go in spiral in notes. I'll warm up in notes. We haven't gotten back to our spiral in a while. We should do that sometimes. Okay. You can see his feet. Some nice feet. Yeah. Something. A couple pixels at least. So, question. We are in section 4.3, and if you remember, 4.3, SOHCAHTOA CHOSHIRKAO. Tell those who are gone what SOHCAHTOA stand for. Sine of an angle.
Opposite over hypotenuse.
Opposite over hypotenuse. Cosine is
Adjacent
over hypotenuse, and tangent is
opposite over adjacent.
okay. What's CHOSHIRKAO?
That's
Cosecant
Is hypotenuse over opposite.
Sha
secant is
Cow.
Cotangent is
Adjacent over opposite.
Exactly. Does that make sense? So we have SOHCAHTOA CHOSHIRKAO, and we were solving right triangle. You like it. Right triangle problems, right? Question, real quick. This one from Friday, the last one we did. How did we know to use cosine and sine?
Because of the size.
We figured out the sides. They gave us an angle. Why couldn't we just use Pythagorean theorem? X squared plus y squared is 18 squared. Yay! Because we don't know, yeah. But if you used trig, you knew an angle and you knew a side, you were able to solve. Why did we not get out a calculator?
because we cool like that.
We'd be cool like that, and 60 be in the unit circle.
5/3.
60 degrees, 1/3 of 180, 1/3 of pi, pi over 3, 1/3 of a calzone. Okay, this one you guys were trying to solve. You know a surveyor is standing 115 from the base. I got distracted. 115 feet from the base of the Washington Monument, as shown in the figure below. The surveyor measures the angle of elevation. I don't know why I was made. It's not a flag. The surveyor measures the angle of elevation. Oh, we even marked it for you guys. Laziness. That's okay. Surveyor measures the angle of elevation to the top of the monument at 78.3 degrees. We need our calculator. That's not in the unit circle, right?
Yeah.
Okay. How tall is the Washington Monument? What are they asking for? Mathematically, find y. When theta equals 78.3, and now I know x, but let's label this by size. Who is x? And adjacent equals 115, and to be consistent, let's not say find y, let's say find who? Why is that nice?
Because it tells us what we
What uses him and him? Toa or cow, but we don't. I mean, if we have an option between cotangent and tangent, let's use tangent. Also, because in your calculator, is there a cotangent button?
There is? No, there's.
So that negative means inverse. That means backwards. Don't use that. What's the only way to do cotangent in your calculator?
1 over
1
tangent.
divided by tangent of the angle. How do we do secant in your calculator?
1 over
1
cosine.
divided by cosine. How do we do cosecant? 1 divided by sine. That makes sense? Don't use those negative buttons yet. No. Only one co. Sine must go with cosecant.
True.
Cosine has to go with secant. Only one co. Okay. So you guys use tangent. Tangent of who? And since it's in this, what mode? Degree mode. Do you need to be in? And I have equals. Yeah, careful. Opposite over adjacent. Who is opposite? Y over who is adjacent? 115. And then all we had to do was y equals 115 tangent of 78.3 degrees. What do you guys get? Y approximately, because you're going to round. 155 point?
No, 555.
Oh, it's a little bit bigger.
Shit, that's tall. Is that the actual height? Is that the actual height?
Maybe you should research it. What, 3 decimal places? 314? Ooh, like pi. Feet. Nice. Put a label. Otherwise, it could be inches. That would be a very small Washington monument. Are we researching this to see how accurate? Now remember, he's measuring an angle of elevation, so therefore it might not be all that accurate. While he measured, while I see how tall the Washington Monument is reported to be, you guys are going to set up one last bit of notes for this section. Go. The Washington Monument. How tall is the Washington Monument? How close were we?
Ooh.
555 feet. Lincoln Memorial, that's kind of cool. The White House, and then the Capitol. It's pretty tall.
555, that's a lot.
That is a lot. That was fun. Okay, go back. What did we get? 555.314? Not bad. I bet he rounded to the nearest tenth, and that's how he got a little bit of error. Either that or online they measure to the nearest whole number. I feel like if we were there with a protractor, we wouldn't do much better. Probably much worse. Okay, this page gives us one last snazzy relationship. Trig of complementary angles. Let me give you a few complementary angles. All right. Oh, I need to add something on your list back here. HonorsPrecalc. Let me erase this. Let me put this down. Okay, what are some examples of complementary angles, cool kids? What's the complement to 30 degrees?
60.
Hey, they're both in the unit circle. Hey, what's the complement to 45 degrees? 45. What's the complement to 27 degrees? 63 degrees. Okay. We always subtract from 90. What's the complement of 110 degrees? None is too big, right? So say negative. Trig of complements. Anybody ever wondered what the co and cosine is for? Or the co and cosecant? Or the co and cotangent? They're co-functions of each other. And let me show you one possible application of the co. Ready? Sine of theta equals cosine of 90 minus theta. Cosine is the sine of the complement. Wait, what? And similarly, cosine of theta is sine of 90 minus theta. Interesting. Is this true for all the co-functions? Yep. Secant of theta is equal to cosecant of 90 minus theta, just like cosecant of theta is equal to secant of 90 minus theta. Tangent is equal to cotangent of 90 minus theta, just like cotangent is equal to tangent. 90 minus theta. Co-functions have the exact same value at the complement as the original function at the original.
What if we have sine, cosine, secant, cosecant, and then tangent can only go like because tangent and cosecant it's like sine and cosecant.
Oh. Like sine goes to cosecant and to cosine, and cosine goes to secant
Yeah, but tangent
and to
the
sine.
complementary of tangent is only cotangent. Or it doesn't matter.
I think it's just because with sine and cosine, tangent is already sine over cosine. Cotangent is cosine over sine. So there is no need to go to anything else. Okay, so how can we apply this? Let's say, well, first of all, I need a circle. Have you guys noticed that if we go to pi over 6, where's pi over 6? What quadrant? First quadrant. 1/6 of the calzone. Yeah, it's not the second quadrant yet, right? He's good. Okay, pi over 6. First quadrant. Okay. Have you noticed that? Hold on. What are the ratios? What are the x and y at pi over 6? Over a lot, up a little. Okay. Do these correspond or relate to any other angle in the first quadrant? Doesn't it relate to this one? What's the difference? They're flipped, right? What's the relationship of these two angles? If we call this theta, it's pi over 6. What's this one of pi over 3? Now it's hard to see when it's written like this, but what's another way of writing pi over 3? 2 pi over 6. What's the relationship of pi over 6 and 2 pi over 6? What do they add up to be? 3 pi over 6 or pi over 2 are 90. They're complements of each other. And what's true about the cosine of 1? It's the sine of the other. And what's true about the sine of 1? Sorry, that's a pi over 3. What's true about the sine of 1? The cosine of the other. And that's true for any set of complementary angles. So let's say I was to give you something like, given, this is a quick example, maybe I should have made him red, but that's okay. Given sine of theta is equal to 1/5. What else could we be able to tell from that? Actually, there's quite a bit we'd be able to tell. But what's one thing we'd be able to tell, given these co-function properties?
Cosine of theta.
Not cosine of theta. Cosine of would be equal to? At the complement, cosine will be the same thing. At the complement, cosine will be the same thing. What else could I do? Couldn't I say who cosecant of theta is? Who's cosecant of theta? Cosecant. Oh, we flip it, right? What could I say then about secant of 90 minus theta? Now, you probably won't be asked to come up with these off the top of your head. However, it might come up from time to time. And it is pretty spiffy because would we rather work with a theta or a 90 minus theta? A theta. 90 minus theta is messy. It's yucky. So if you ever do come up against something where it says 90 minus theta, be like, ooh, there's a better way of writing it with the function's co-function. So if you ever do see a 90 minus theta, you can actually go to the co-function at normal theta, and it makes it a lot easier to work with. There's not really much else that we can do with that without some formulas that we don't know yet. So, with that, kiddos, wait to the end of section 4.3. I want to start section 4.4 soon and very soon. But before we start section 4.4, all these are messed up. Look at this. We should sue. I don't know why my screen. What was that? Let's look at the backboard real fast. Okay, good news is it's not today, although it could have been. It could have been like pop quiz, half sheet. No. Why not? Because I want us to talk about the unit circle a couple different ways. Let's just start our notes right here at the end of section 4.3. Because aren't we kind of sometimes using the unit circle in 4.3? We learned it in 4.2 in the sense that we wrote it all down. In 4.3, we had to use it every now and then, only when the angles are nice. And when the angles aren't nice, what are we using instead? Maybe properties, but then also our calculators, like the 78.3, whatever that one was at the Washington one. Okay, let's take a second, and let's think about a few other ways of remembering the unit circle. What are the ways I've given you so far? Thinking about pi radians as a calzone, and thinking about fractional pieces of a calzone. Okay. I've also given you the 5 main ratios in the unit circle. Do you guys remember what those are? The 5 main coordinates that might show up. Sorry, the lowest one. What's the lowest coordinate that might be there? 0. 0 is the lowest, right? What's next? 1 over 2. Root 2 over 2. Root 3 over 2. Interesting. So couldn't we maybe think about our quadrants as counting up? And this, I had to ask George Corey, I don't know exactly how his finger trick works. But couldn't we kind of have our 5 different ratios? And as we're looking at our quadrants, there's 1 and a 2 and a 3 and a 4 and a 5, right? Couldn't we think about starting at 0? 1 over root 2? Sorry, 1 over 2? Root 2 over 2 is technically root 1 over 2, if you want to think about it this way. And what am I counting if I'm counting up? Who starts at 0? The x or the y?
The y.
So I'm counting, and what's the y correspond to? The heights, and the heights or the opposite side corresponds to sine, right? Okay. So if we remember that all of these are the sines, this is kind of what I've already done. If I have the 0, you could think of it as root 0 over 2. You could think of it as root 1 over 2, root 2 over 2, which doesn't simplify. Root 0 is 0. Root 1 is 1. Root 2, I'm stuck. Root 3, that would be right here. Root 3, I'm just counting up 1. And then root 4 over 2. What's the root of 4?
2.
2, and 2 over 2 is 1, right? And then what's the cosine? Well, he just goes the other way, right? So I just go backwards, and I have my root 3, and then I have my root 2, and then I have my 1, and then I have my 0. He just goes the other way. And then if we have our first quadrant, you go second quadrant, third quadrant, fourth quadrant. This is a good way. It's not a horrible way. This is technically the way that my brain thinks of it every time. However, there are 2 other main ways. Okay? Here's one. With triangles. Just a variation. just a variation, unit circle with triangles. What triangles? They're the special ones from geometry. And what were the special ones from geometry?
36 and 90.
36 and 90. And 45, 45. And technically, I'm going to show 3 triangles. Why am I showing 3? Because the 30-60 could be a 60-30, and that could help us for the higher threes, right? Okay. Let's say your brain either A, doesn't think in radians, or B, doesn't want to think in radians. Then you could, for instance, be given something like, and I'm showing you what the answer quiz might look like. You could be given something like, find cosine of 5 pi over 5 pi over 3. I hope you can get that in about 30 seconds or less. Stink. Okay. Either you think in calzones and say, okay, that's 1 2/3 calzone. Or if you really hate radians, and some people even in calculus are still doing this to this day, you could always take 5 pi over 3. Here's one thing, before we even get to the triangles, you could convert. How can we convert that to degrees if you literally just can't? I have the 180 up top and the pi down bottom, right? If it's thirds, here's one way some people thinking about it. If it's thirds, it's 1/3 of 180. Well, what's 1/3 of 180? 60. This is a 60-degree angle, but which one? Well, it's going to be 5 60s. 5 60s. Now, you could technically think about that in your unit circle. Or you could just multiply it and say it's 300 degrees. It's up to you. If you were to think about it in your unit circle, you'd say, okay, there's 1 60, there's 2 60s, because it's thirds, 3 60s, 4 60s, 5 60s. Whether you think about it as 300 degrees, whether you think about it as 1 2/3 calzone, or whether you think about it as 5 60s, you should end up at this location. Now, once you get to this location down here, okay, if we were to fit one of these triangles in, well, wait a minute, hold on, what's the point of the triangles again? In geometry, you learned the 30, 60, 90 would be 1, 2, root 3 as ratios, right? 45, 45 would be 1, 1, root 2. And if we were to flip this one on end, 30, there's the 1, 60, well, 2, and then root 3. Why am I showing this? What kind of angle is this as demonstrated by the 1/3 of 180? It's a 60-degree triangle. You could not, it's a little bit cheating because the unit circle technically only has a radius of 1. But you could, this goes out to 2 and that's okay. You could think about this as having this triangle, the 60-degree one, and saying, hey, I have 1, I have 2, and I have root 3. But the 1 is positive and the root 3 is what? Negative, because you go down. Then you could think of all of your trigonometric ratios by thinking of SOHCAHTOA and HonorsPrecalc. Because you could look at this one little triangle and you could say, what is sine? Opposite over hypotenuse. What is cosine? Adjacent over hypotenuse. What's tangent? Opposite over adjacent. You could do HonorsPrecalc the same way. Hypotenuse over opposite, adjacent over opposite, and adjacent, hypotenuse over opposite, I'm doing this backwards. Hypotenuse over opposite, hypotenuse over adjacent, adjacent over opposite. Anyway, you can find all 6 using a triangle instead. Let me do one more. Well, hold on. First of all, if I wanted cosine of 5 pi over 3, how would I finish this example then? What's cosine of that little triangle that you see? Right here. Adjacent, here's your angle. Adjacent, 1 over hypotenuse. What if I was to give you another one? What if I was to give you, let's do tangent of 5 pi over 4. If you're thinking calzone, you say 1 and a 4. If you're thinking degrees, what would you do?
225.
Every time you have fourths, 1/4 of 180 is always going to be 45. Oh, this is a 45-degree triangle. And 5 45s puts us at? It ended up being 225. If you want to think about it in terms of the circle, 45s cut it in half, right? So 1 45, 2 45s, 3 45s, 4 45s, 5 45s. You're right here in the third quadrant. You could then throw in your 45-45-degree triangle and say, hey, it's a 1 1 root 2. Except I'm going left, so that's a negative, and I'm going down, that's a negative. And you can say, sweet, what's my tangent? Opposite over adjacent. That's -1 over -1. Positive. Now, real quick, before we move on, those of you guys that would get there with, can you finish it? That would get there with the coordinate or the ordered pair instead. What would our x be over middle? And what would our y be? And how would we find tangent? Y over x, right? And they're the same thing. Oh yeah, it's positive 1. Now for those of you that are like, all students take calculus, yeah, that's a thing. What does that mean? In the first quadrant, x's and y's are positive. So x is positive, y is positive, 1 over x is positive, 1 over y is positive, y over x is positive, and x over y is positive. They're all positive. In the second quadrant, an ordered pair over here, who's negative now? X is negative. Who's positive? So x is negative, y is positive. 1 over x, secant, is negative. 1 over y, cosecant, is positive. Y over x is negative, x over y is negative. All students, sine and his reciprocal. All students take. Oh, sorry. Which ones are positive? My bad. Sine is positive and his reciprocal. Everything else will be negative. We already looked at this one. X's are negative, Y's are negative, 1 over X's are negative, 1 over Y's are negative, but tangent and his reciprocal are positive because a negative over a negative is a positive. And if we were to go in the fourth quadrant, all students take who's positive over here? The X is positive, but the Y is negative, so cosine and his reciprocal are positive, but the rest is negative. That was the way that Mr. Crawford had of remembering all students take calculus, the signs in each of the quadrants. This is the triangle way. Let me show you one more way, okay? The chart way. And of course, somewhere in the midst of all these is a just flat out memorize way and write the unit circle the whole time, the whole way, and then just use it for your quiz. That's the other. The unit circle, one more. The chart way. I'm going to show you the idea of it real quick. The chart way. There was a kid I was tutoring in college. She only made it through Algebra 2 here when she was at, LED back then. Then she went to college, took a math placement test, basically had to go back to geometry and work her way up all the way through business calculus. It was a little bit rough, but she was really good at studying, really good at memorizing. She ended up figuring out that this was the way that worked for her. She would put this on the top of any quiz, any test that might possibly have the unit circle, and she would use it for the entire quiz and or the entire test. She only had to write it once, and she could use it to solve any unit circle thing that might appear. She would always put sine, then cosine, then tangent. You can think of it, sine over cosine is tangent. And also, if you think about a little finger trick, sine is the one that counts up. She counted up from 0 to 30 to 45 to 60 to 90. She did it in degrees, and she always went from radians to degrees, just converting, so that she didn't have to stress about it. Then she would go ahead and count up the way that we count up and just do 0, square root of 1 over 2, square root of 2 over 2, square root of 3 over 2, square root of 4 over 2. She just memorized it. Then she would go backwards. Then she would do sine over cosine. 0 divided by 1, 0. You get tangent. 1/2 over root 3 over 2. The 2's cancel. You get 1 over root 3 or root 3 over 3. You can rationalize it. Root 2 over 2. Root 2 over 2 is 1. Root 3 over 2, and then undefined. What would she do if it was not in the first quadrant? all students take calculus, and she would ace it every time. Some of you, maybe this is the way to go.
30, 35.
Start putting your unit circle. Tomorrow we'll have a dum-dum quiz. What's that? We'll find out, but it's not one for a grade. You study, you get study, you study.
That's all I wanted.
With the song?
With the song.
Was it kind of like the chart?
Yeah, that's how my teacher taught me, but the 30, 45, and 60 is 1, 2, 3, 3, 2, 1, everything over 2, square root of 3, over 3, 1, square root of 3.
That's cool. I like it. I like it. That's a good song. Oh no, so we have to match it? Okay. Alright, thank you, Elena.
Every time I see
You too, Leah. See you next time.
Those are extra ones.
Okay. The blank ones, right?
Yes. And then here's the A and B. Bye, Stacy. Yeah.
Have a good rest of your Monday.
You too. Oh, I'm gonna take the final quiz.
Okay.
Yeah.